Good morning to all of you. Uh, just to, we will revise the previous discussed topics. The last class we discussed about that pyrometers. Pyrometers are the instruments which is used to measure temperature. These pyrometers are non-contact type of devices or sensors. In that, we discussed about the optical pyrometer. This optical pyrometers works on the principle of this monochromatic source of light that is emitted from the uh, body whose temperature has to be measured. And then when the radiations emitted by the body, hot body, is focused on that device, and then with the help of some arrangements, that is we have to adjust the rheostat. Inside one filament is there. That filament where it appears dark means that means we have to adjust the rheostat in such a way that, for example, if it appears dark, then what we have to understand, the reading is a wrong reading. That is not equal to the temperature of the body. That means it is the temper. That means whatever the current, we have to calibrate in terms of the temperature. That is which is produced in the meter, that current. That it is displayed in the ammeter or multimeter. The next, if the filament is disappears, then we have to understand. We have to adjust the rheostat such that with the help of the eyepiece, the observer can observe if the filament is disappears, then both, that means the brightness, whatever the radiations emitted from the body, that brightness and the filament brightness both are same, so the filament disappears. Then at that point, current we have to calibrate in terms of the temperature of that particular hard body. And the next, if the filament is bright, then you have to understand that it is wrong reading, that is more than the temperature of the body indicating. So we have to take, when the filament, we have to adjust the rheostat in such a way that the filament disappears. That reading only we have to take that current value, and then we have to calibrate in terms of the temperature. That is about the optical pyrometer. And then the infrared pyrometer. That is all of you know that here that instrument emits radiations, as well as the targeted body also emit radiations. Here in this especially, all bodies, all objects, uh, it emits infrared radiations with small wavelengths, which is harmful, which is less harmful to the human beings. And then here the instrument emitting radiation, it falls on the targeted body. Similarly, the radiations emitted from the hard body is focusing on the instrument. Thereby one detector is there. In the detector, it detects the radiations of the hard body, and then this radiations is converting into heat. Thereby we can measure the temperature of the body, targeted body, which is displayed in the monitor. That is the process. What we discussed, one person, one student said, see here in our security, so almost all every student they are checking the temperature of the body, right? So same similar, it is infrared parameter. And also these pyrometers is we can go for several applications. Already we discussed the boiler temperature, we can measure furnace temperature, we can measure oil temperature, we can measure. So like this, there are several applications. These are purely non-contact type based devices. That means if the body is too hot, means we cannot. It is very just we have to, with the help of the infrared pyrometer, just we have to click whatever the rays falls on that particular body, and then the whatever the target focused, that is the light is dropping down. That from that point only it takes the detector takes the radiations, and then whatever that having radiations, all whatever the emitting radiations is having heat, that heat is calibrated. That means whatever the heat generated, that is nothing but the temperature. You can with the help of some thermocouple or thermopiles, we can measure the temperature of that radiations emitted from the hot body. So that is the thing. And also we discussed yesterday weight, that is about pressure measurement devices. That is a dead weight tester, right? Dead weight tester. We discussed a dead weight tester. Just I will go through again. I will explain. I will explain to you this dead weight tester. Simple for an about of 2 to 3 minutes. Already yesterday we discussed this one. Again, I will explain. All of you listen carefully. See here in this dead weight tester, first this test gauge is not there. Test gauge is not there. First test gauge is not there. See here, it consists of weights which is placed on the platform, and then a piston is there, and then a piston is moved inside the cylinder. This is a cylinder, and here the handle and the plunger. Plunger is available, and then inside oil or some liquid is there. And then here when the weights are placed on the platform, then what happened, the piston drops down, thereby the pressure creates in the oil. And then similarly, here when you press this handle, this plunger moves towards in this direction, and thereby the pressure creates some pressure creates. Once handle, if you press this handle, see here in this direction, automatically the pressure created is more. Then what happens means that this piston will floats between these two limit stops. This is the two limit stops. Then we have to stop. And then with the help of this formula, you can go for find out the pressure. That is a P is equal to mg plus f by a, where m is the mass, that is the weights adding on the platform, g is acceleration due to gravity, and f is friction drag, and a is the equivalent area of piston cylinder combination. And this, see, after calculating pressure, we can get the value of the pressure now. Now, especially this dead weight tester is used for the calibration of a pressure gauge. So now, here now I am inserting the test gauge, right? Yeah, here I am inserting the test gauge. Test gauge means the gauge has to be tested whether it is working correctly or not. And the next, see here what next same procedure, same experimental procedure we have to perform. So now here the test gauge, that means the gauge we have to test. That one we have to incorporate in that, and this is a wall. And then here a platform is there, and then same similarly weights are added. The piston drops down, and then here same the plunger we have to push the plunger. That means we have with the help of the handle, then automatically inside the pressure created. Same procedure here, this piston will moves up, and there it floats in between the two limit stops. Then at that particular point you have to note down the reading of this test gauge. So here, this whatever the reading you got and whatever the theoretical reading from this calculation you got, these two should be coincident. Then only you can say that is the procedure, actually the calibration procedure. Then we can say the gauge is working properly. That is if it is not, some error is there means, then you have to adjust in such a way that correctly. Maybe some errors are there, so we have to adjust such a way that correct reading. Then the calibration process is complete, right? So actually that is the process. Yesterday we discussed that one. The next, see here same this one calibration of a pressure gauge using dead weight stage. What we discussed now same. See the applications. If you go for it is used in calibrated all kinds of pressure. Here, if you observe here, all kinds of pressure gauges. With the help of this dead weight tester, we can go for calibrating of all pressure gauges. That means all whether the pressure gauge is the reading is giving correct or wrong. Then if there is any errors miss, then what we have to go for? We have to go for You have to take the consideration of that error, and then you have to make it correct. And this is such as industrial pressure gauges, engine indicators, and piezoelectric transducers. The piezoelectric transducers also we can go for. These are the applications of dead weight testers. So same here. They see here, this is a screw. Here in the previous case, it is a handle, but here it is like a pumping, right? You have to rotate the screw, thereby the pressure creates inside the oil. And here the dead weights are added, and this is the piston. This is piston. Up to this is piston, right? And this is the piston, and then this is a gaze under test. Same procedure, but here the figure is different. That figure is experimental, and this is also same figure. But here the arrangement is a screw arrangement and pumping section. We have to pump it. So thereby the inside the what happens means the pressure created inside the oil. And then same with the help of the theoretical formula. And then so after gaze under test, that pressure should be equal both. The next, if you see here, dead weight pressure gauge test, it is a simple in construction. The advantages here, it is a very simple in constructions, that is easy to use, and it can be calibrated a wide range of pressure measuring. That means the calibration is mainly the advantage of this one is calibration of a pressure measuring devices, calibrations, right? And then fluid pressure, that means this one we can go for either fluid liquid, or we can go for air also, right? By adding weights or by changing the piston cylinder you can, you can also change the piston cylinder combinations. The next we'll discuss about the bored on tube pressure gauge. Today's topic is bored on tube pressure gauge and diaphragm gauge. So these are also used for pressure measurement. Here, this compared to the bored on tube, the diaphragm is a very sensitive element. Sensitive element. Then any questions on dead weight tester? Anybody? Dead weight tester. Questions. Any questions on dead weight tester? Dead weight tester. Any questions? Dead weight tester. Any questions on dead weight tester? Dead weight tester. No, are you understand? Are you understand? Dead weight tester. Number lateral entry 33. Lateral entry 33. Are you understand? Hanif. Lateral entry 33. Whether you are there or not. Lateral entry 33 section B. Pressure gauge. So Chandu, better rename your name, Mister. Bow better rename. Chandu. Rename. So what is your doubt? What is your doubt? Chandu. I'm asking about Chandu. Chandu. Chindu. Whether you understand or not. Chindu, I'm asking about Chindu. Just one person posted. Okay. Chindu. Rename fast. Right. Lateral to 352. So in the which one you are not understand? Dead weight pressure gauge. Dead weight pressure gauge. Which one you are not understand, Mr. 350 to 352? Chandu. Which one? Which one you are not understand? I will repeat that one. Okay, right. Okay, right. Again, I will repeat you. No problem. No issues. I will repeat. See here, you listen carefully, Mister. See here in this dead weight, already I discussed yesterday this one topic already we discussed. This is the revision topic, revision today's. I will explain you again. All of you listen carefully. See here in this apparatus consists of a dead weights, the piston and cylinder. This is the cylinder arrangement. This is the cylinder arrangement. This is cylinder, right? And then inside oil whose pressure has to be measured. And then at the other end of this equipment or a device, a handle is there and a plunger is there. So here when you place first here the test gauge is not there. Remember this point, test gauge is not there. We have to place weights on the platform, thereby what happens means the piston drops down, right? And then here the piston drops down completely, the piston drops down. And then from this, with the help of the handle, we have to push the in this direction. And then the plunger moves towards down, thereby inside the pressure created in the oil. This pressure leads the push the piston, this piston ups, and then the piston will floats in between these two limit stops. Then we have to stop that experiment. And then with the help of this formula, P is equal to mg plus F by A. With the help of this formula, we can find out the pressure. Okay, right? We can get the theoretical value. So we can get the value of the pressure, right? And then next, what we have to do is uh, same procedure, same experiment we have to perform again. But here we have to add now the test gauge. Here the test gauge, we are adding the test gauge at the other end. So test gauge means here we are testing the pressure gauge whether it is working correctly or not. So remember this point. And then this, especially this dead weight tester is used for the calibration of so many pressure gauges, which is used in different applications. So now here, now the test gauge, this is the test gauge we have to attach at the other end. Now the same experimental procedure we have to proceed. Same, we have to add weights on the platform, and then this piston will comes drops down. And then on the other hand, the handle, we have to press the handle, and then the plunger moves in this direction, thereby what happens inside pressure created in the oil. And then same similar, the piston moves up, and then it will be floats in between these two limit switches, we have to stop. And then we have to check the in the test gauge pressure reading. If that pressure reading is equal to the theoretical value what you calculated from this with the help of this formula, both are equal, then we can say the gauge is working correctly. If does not work, that means it shows some error, then you have to go for make it correct. So by adjusting, by making some arrangements, so we have to go for adjustment such that it will shows the correct reading the next experimental experiments. So now it is clear. Number 352 na 352. Okay, okay, okay. The next we will go for board-on tube pressure gauge. Here, this board-on tube, all of you know that it is having some features. This board-on tube having some features. Uh, so 1 minute. Board-on tube having some features. So now it is all members. It is audible. Here, or it is hanged. Wait, it is hanged. 1 minute. Right, now it is okay. The board on to pressure gauge. So that means it is the tube having a future that it expands. Here the board-on tube gauge, it is a coiled tube and it expands when the pressure increases and it causes, see here, it causes a rotation of an arm connected to it. Now I will explain you clearly. So now here, this is actually with the help of this principle, it is working. Here, see here, we are applying, this is a board-on tube, this is a tube, right? This is a board-on tube. And this is a rod, connecting rod between one end of the tube to the rack and pinion. This is a rack and pinion arrangement. This is a rack and pinion arrangement. And at the middle of the point, we have to pivoted a needle. This is a scale. This is a pressure reading. This is a pressure reading scale. So here, when you send the pressure, the inlet for applied pressure, it may be in air pressure or a fluid pressure. Fluid means what is the meaning of the fluid? It is maybe a gas or a air. So here we have to send a fluid whose pressure has to be measured. So here this inlet, we have to connect it to the some particular unit section. So for that we have to prepare some of the fluid we have to send to the board-on tube. This is the inlet whose pressure has to be measured. Here this board-on tube is used to measure the pressure of a compressed air or a pressure of a fluid. That means liquid on or air. And see here, when the air sends into the board-on tube, automatically what happens? It expands. It is like a coiled tube. It is like a coiled tube. So, but it is not circular. Remember this point. It is not circular. See here, this is the board-on tube is up to this point only. Up to this point only. This is the free end. See, if you observe it here, the board-on tube is this is the free end. It is not in circular shape, right? Sorry, somebody said that here we are saying that rotation, then it is completely circular. No, no, it is not in the circular shape. And then see here in this rack and pinion arrangements, this is a rod which is connected between the free end of the board-on tube and the one and other end of the rack and pinion arrangement. This is a rack and pinion arrangement. And then pivoted, we have to pivot here. And then see here, when the fluid sends into the board-on tube, whose pressure has to be measured, then automatically what happens that due to the here the pressure more, what happens means the board-on tube expands. Same similarly, take our balloon. So when we give the air, that means a gas, balloon gas. When you input give the pressurized gas, then what happens means then automatically the balloon expands. Same similar feature for this board-on tube is also. Then if you send the a fluid whose pressure has to be measured, then automatically the tube expands. And then see here, it rotates sometimes. Here, after this is first at this position without sending the fluid. So after sending the fluid, then this is the position. See here, this is the position. That means it expands and then it undergoes a rotation. And then once it expands means thereby this rack and the pinion arrangements will be moved to will be motion thereby which is here needle is placed on this uh, pinion, then automatically what happens, the needle will deflect on the scale that indicates the pressure of the fluid, the pressure of the fluid that indicates the pressure of the fluid. That means it's a simple arrangement. Here the mechanical arrangement, this is the only here we have to connect a rod between the free end of the board-on tube to the uh, rack. And then here one pivot, and this is the rack and pinion arrangement. And at the pinion, we have to arrange a needle, and this needle will deflect on the scale. Whenever the board-on tube rotates or it elongates or it expands, then automatically the connecting rod also will move. Thereby, the rack and pinion arrangement also will there is a movement, maybe clockwise or anti-clockwise, that depending upon the pressure, then the needle will deflect on the scale. Then it shows the reading of the pressure. It's a very, very simple arrangement. Okay, are you understand all this one? Pointer and scale arrangement, right? Now it is clear to all of you. So 1 minute here, there's some disturbance is occurring for me. So wait a minute. This is some technical issues. Okay. The next, see here, application of a board arch. See here, already we discussed LVDT, right? In the LVDT, the core is moving. Here, the core is moving between the primary and the secondary coil. Here, the core is moving here with the help of the board arch. We can move with the help of the board arch. Here, with the help of the board arch. You can also move this one with the help of the board. That means when the board-on tube expands automatically, here we have to arrange with the help of the pulley, then automatically, if it will move in this direction, the board-on tube expands, it moves in the direction, then automatically the core will move upwards. So we can use any, we can, that means we can send some pressure, pressurized here, then automatically it will expand. So thereby, this LVDT, that core will moving top to bottom, top to bottom. So here, this is the primary windings and this is the secondary windings, two secondary windings which are connected in series. Already we discussed this LVDT, linear variable displacement transducer or linear variable differential transformer. See, the materials of this board-on tube is, you see, phosphorus, bronze, silicon, bronze, beryllium, copper, inconel, etc. There are so many materials are there for the board-on tubes. What are the materials? Phosphor, bronze, silicon, bronze, beryllium, copper, inconel. So, okay, right? Clear? Board-on tube pressure gauge. Anybody any questions? Board-on tube pressure gauge. Okay, right. And this is actually, this is a board-on tube instrument, board-on tube instrument. If you observe, this actually, this is the inside of the tube. See here, if you observe clearly, this is the inside of the tube. This is a connecting, this is the board-on tube. See here, board-on tube, this is a tube, board-on tube made of phosphor bronze or silicon bronze. And at the end, this is a connecting rod and a pivot, and here a rack and pinion arrangement, and here a needle will be attached. See here, if you observe clearly, this is see here, right? This is actually, this is in this direction. Board-on tube is in this direction. This is a board-on tube. At the end of this one, we have to go for connecting rod, then rack and pinion, some arrangements, mechanical arrangements, and thereby here the needle will be deflected. Here at here we have to go for pointer. Have to arrange a point. So here this is the top. This is the top one. Here we have to send the fluid whose pressure has to be measured. Maybe either a gas or a liquid. Yeah, this one. This one. So now it is clear. Any questions? And in this, there are so many types are there. If you observe clearly, this board-on tube pressure gauge, and this is a C board-on tube. See here, this is a C board-on tube. C board-on tube. See here, this is some arrangements. See here, this is connecting rod here, and what we discussed now, C board-on tube. And this is a spiral. See here, process pressure. We have to go for process pressure at here, and then thereby the board-on tube expands. If the pressure is less means, then it contracts. If the pressure is more means, then it expands. Thereby here some arrangements. Pointer is that pointer deflects on the scale. That means in board-on tube, C board-on tube, or spiral board-on tube, and helical board-on tube. So here in this, we have to send the fluid whose pressure has to be measured. And then here, this is the helical. Here the moving tip here, the expansion will takes place in this direction. here in this direction, the expansion will take place in this direction. The expansion will take this tip will expansion both. Here it should be like this, right? The expansion will take place like this. This here it is like this, and the expansion will take place like this when the fluid descends into the tube, helical tube. This is a helical tube. Here the expansion taking place at the tip only. See here we can say it is this tip will move in this direction, and this tip will move in that direction. Right, right, correct. Any questions? Any questions on board, aren't you? Any questions on board, aren't you? Board, aren't you? Board, aren't you? Any questions on board, aren't you? The next, okay, who will, whether you understand or not. Winding diagram. So winding diagram is spiral. Spiral, mister. The previous slide, number 320, regular. Previous slide. Yes, okay, okay. Okay. So what is your question? Another previous. Okay, another previous diagram. Disadvantages means, of course, this is another. Okay. Here, disadvantages, maybe it's no disadvantages. For example, when the disadvantages takes place means here this bolt-on tube, if the depending upon the material, it will works within that limited pressures only, within the range of the pressures. If it is more means, then it will create some problems. For example, in the boiler, the pressure creation will be more. Sometimes we have to handle maybe the bolt-on tube will not work, and maybe the diaphragm tube is also will not work. Diaphragm gauge also will not work. So at that time we have to arrange. Maybe, for example, if you observe 1 minute, if you observe in the, for example, so the air is filling in the tube in our bikes, right or wrong? Right or wrong, Mr. 20? Air is filling in our bikes, right? When the air is less in the tire, then what we have to do? We have to go to the filling station. Then with the there he has to use with the fill the air in the tube of the tire. Am I right? 320. So here the compressor is there, right? First he has to store one tank is there. That is the air is compressed and it is stored in the tank on the with the help of the gauge. He is tested before while injecting the pressurized air into the tube. First he has to test with the help of the pressure gauge. In that pressure gauge, it's a Botan tube. It is Botan tube. There, it is a Botan tube pressure gauge. And also on the top of the that is a compressed air tank. In the air tank we are storing one cylindrical shape. Whether if you go there you can observe clearly there one tank, cylindrical tank. In that also in the top one pressure gauge is also placed. That indicates what happens means that indicates means why it indicates means that tank is filled up to that limit of pressure. If it is more than that limit, then it exceeds that limit. What happens means it fails. That means damage will create. So even see even in our pressure cooker, if the pressure creates more inside, what happens means that pressure will goes out. So thereby the whistle, we can hear the whistle sound, right or wrong. That indicates the inside the pressure is more, it will goes out. For example, it will not goes out means it will create problem. So with the help of this pressure gauge, it will be limited. When you send more pressure inside the gauge, automatically the bolt-on tube, the material is very sensitive. It will be gets damaged. So we have to use this bolt-on tube within that limited range of pressures only. Okay, that is the actual. It's a very sensitive element, right? If you see, observe, this is actually, this is a bolt-on tube, right? This is a, in other words, this is a bolt-on tube, and this we can call it simply pressure gauge. We can call it as a pressure gauge, which is used to measure the pressure of a compressed air or a pressure of a fluid. See here, in terms of Newton per meter square, Newton per pressure reading is a Newton per meter square, or in terms of Newton per millimeter square. According to our requirement, we have to design the scale. Okay, right? Number 39 lateral entry. The pressure reading, it is Newton per meter square or Newton per millimeter square, right? Here, if you observe clear here, one side having some pascals reading, or maybe one side should be the Newton per meter square. Yes, you're absolutely right. There, according to their requirements, the scale, the units may change. Yes, industry shows different scales. Absolute right. So according to their requirements, the units may be changed. Correct. Next, we'll go for a diaphragm gauge. Uh, so just 5 minutes. All of you listen carefully. Diaphragm gauge. Shall we discuss, or we'll discuss the next class? Hmm? It will take another 10 minutes time to discuss. Okay, diaphragm gauge. Listen carefully. Diaphragm gauge, here it's a very sensitive element. If you observe here, it's a very sensitive element. This is a diaphragm gauge. When the pressure is applied on that, it undergoes a small deflection. So that is why. So this diaphragm can use elastic deformation. That it undergoes here. This is deformation. That means it will bend. So when the pressure, uh, that means if you apply pressure, it undergoes some deflection, right? See here, it undergoes some wide displacement, right? And then in these two types of diaphragms are there. One type is a flat diaphragm. It's a very thin membrane. That's a very sensitive element. See here, this is a corrugated diaphragm. This is a the corrugated diaphragm, and this is a flat diaphragm. Here two types. One is flat diaphragm, and the other one is corrugated. What is the working principle? When the pressure is applied on that, then it undergoes a small deflection, right? Here, for example, if you apply the pressure in this direction also, here the difference between unknown pressure we can measure with the reference pressure. Here one side is a, if you apply the known pressure, another side is unknown pressure. With the help of this one unknown pressure, we can measure. Here the diaphragm is made of silicon, which is a thin circular membrane. It's a very thin material. Chala sunnitamaina. It's very thin. Right. Next. See here, actually, this is used. See here, if you observe clearly what I informed to you. See here, one side, this is a diaphragm gauge. This is a diaphragm gauge, right? Right. And see here, when the pressure, when the this one pressure, and this is a reference pressure. This is known value, and this is the pressure what we have to find out, right? As here, what happens means the difference here this side the pressure varies and this side the pressure varies. So thereby it undergoes the deflection. This is nothing but the P extension minus P references. So that means we can get that the difference of this pressure also here. With the help of this diaphragm gauge, we can also measure the difference in pressure. And then the applications of this diaphragm gauge. See here, if you observe, this is a pressure sensing diaphragm. When you send pressure inside in this direction, then automatically it undergoes deflection. That means these applications, it is used in a piezoelectric meter. Already we discussed a piezoelectric transducer, right? What is the principle of the piezoelectric transducer? When the pressure applied on that piezoelectric material, like natural crystals or synthetic crystals, natural crystals is quartz. When the pressure is applied, automatically what happens? It undergoes, there will be change in the dimensions, or it undergoes a deformation. Thereby, the electric current is produced. Similarly here also, Here we're arranging, this is a small pressure applying on the crystal. See here, when the pressure is applied on this one, then automatically this diaphragm will undergoes deflection. Thereby, the pressure applied on that crystal piezoelectric material, then automatically there will be change in the deformation. It undergoes deformation, change in the dimension. That means change in dimension undergoes deformation. So we can get the output that is correct. Can get the output correct. So and also we can also use, for example, this is a thin membrane, right? See, for example, it is like this. Example, one pressure, right? Right. See here, if you observe it here, uh, see here inside here one opening is there. For example, if you send the pressure in this direction, this diaphragm gas it undergoes some deflection. So whatever the pressure inside it here, it will goes out. So that means so we can also make this type of arrangements also. So whatever the pressure at here, it will goes high pressure, it goes out. For example, this is same similar procedure. For example, if you open the window, what happens means if you open the window, so here you are staying in the upstairs. If you open the window unexpectedly, then what happens? The free air will get more, right? So what is the meaning of that? Inside pressure is lesser compared to that of the outside pressure. Same similarly, same here also. Here, if the pressure increases at this point, then the diaphragm it undergoes a deflection. Some pressure created, that pressure will go south. That means here the this direction, the pressure is more at here than at this outside environment. So, for example, if you observe in the kitchen room, so we are arranging the exhaust fans, right? Here, the inside in the kitchen fan, the fans are more. Here, the more pressure. Thereby, with the help of the rotating fan blower, so it will sucks the whatever the high pressure in the room, it will goes out. So that means they can use such types also. This diaphragm. That means only small pressures, very very small pressures. This diaphragm gas is used for, remember this point, very very small pressures only. This diaphragm gas, it's because it's a very very sensitive element. Now respond your attendance one by one. Time is over. Respond your attendance. uh, so all of you attempt a quiz. Here some of the members they are not attempting. 18th batch 320 and 18th batch 381 and 1, number 1, 2, 2, number 2, 2, number 2 option 3, 5 option, try 5 present, okay, 6, 7, 6, 7, 8, 9, right, 10, 10, 11, 12, 13, right, 13 and 13, 13 option, 13 option, right. 14 present, 15 present, 16 present. Next, fast 17, 17, 17 option, 306 present. 17, 17. I'm asking about 17 option. 18 present. Okay, correct. 19 present. 20, 21, 16 present. Okay, 20, 21, 22. Right. 23, 23, 24, 24, 24. I'm asking about 24. Okay, 308 present, 306 present. 24 option. 25 present. 26, 26 present. Next, fast. 26 present. 27 absent. Right, 27, 28 present. 29, 30. 29 present. 30, 31, 32, 33, 34, 35, 36, 35 absent. 30 present. Correct. 35 absent. Right. 30 present. Okay. Right. 30, 37, 38, 38, 39. Okay. Right. 37 present. Okay. 40. Okay. Right. 40, 41. Okay. 36 present. 38 absent. 38 absent. 35, 38 and absent. 41, 41, 42, 43, 43, 43, 44 present. 45, 46, 47, 48, 49, 49, 50, 48 absent. 48 okay present. Okay. He is suffering. 50 right. 51, 52, 51 absent. 51 absent. 52, 53 present. 54, 54 right. 54. I'm asking about 54. 55, 56, 57, 58, 59, 60 right. Okay. 61 right. Lateral entry 1, lateral entry 1, 2, 3, 58 present. Okay. 3, 3, 4, 4 lateral entry 4, 5, 6, 6, 7, 7 lateral entry 7, lateral entry 7. I'm asking about lateral entry 7. Okay. 7 absent 8, 9, 10, 11, 12, 12, 13 okay right. 14, 14 absent. 14, 15 present. 14 absent. 15, 16 present. 12 present right. uh, 17 present. 18 present. 19, 19 lateral entry 19, lateral entry 19 right. 20, 20 lateral entry 20, 21, 22, 20 to 23 present. 24, 24, 25, 26, 26, 27 right. 28, 29, 29, 29, 29 lateral entry. 30, 31, 31, 31 is absent right. 32, 33, 34, 35, 36, 36, 37, 36 absent. 37, 38 okay. 39, 40, 41, 42, 43, 44, 45, 46, 45. I'm asking about 45. Okay right. 46, 47, 48 present. 45 absent అంతే కదమ్మా. 48 45 absent. And 48 up to 48 present. 49, 49, 50, 51, 51, 52, 53, 53, 54, 55, 54 present. 55 present. 56, 51 present. Okay right. 56 56 right. Here just I will read the absentees. 32 that present amount that. Here just all of you check. Here the absent is regular section A. Uh, number 1, 2, 3, 7, 10, 13, 17, 24, 27, 35, 38, 41, 43, 51, 54, 55, 57. And then lateral entry, uh, regular 310, okay. Lateral entry 7, 14, 20, 29, 31, 36, 45, 56. So those are the options. Regular 310 present, okay. Lateral 352 present, okay. And 56 is also present, okay. Okay, thank you to all of you. You better attempt the quiz.